Okay, it's time for week 8, homework number 2, and this is the first of the word problems for the week. And there's going to be a second set of word problems. And the idea behind these is not too bad, but sometimes the algebra gets a little bit cumbersome. So I really encourage you to work through these with me and pause the video and rewind if you need to, and make sure that you can do the algebra and that you're following the logic behind the steps. So for this first set, it focuses on two things. The first type of word problems is the area volume ones, and those tend to be a little bit easier. And then the second type is the distance and time ones, and those are a little bit more difficult. And I'm going to do the distance and time one where it talks about the two poles. And then I will save for our recitation this week one of the problems where it talks about someone trying to get out to an island, and they walk for a little bit and then they swim for a little bit. So if you're curious about one of those, I will cover that in the recitation this week. So I'll get one of those just ready to go. All right, so for the first problem, the idea is that we have this piece of cardboard and we're trying to make like a little box without a top so that we could store stuff in it. And I don't know if you've ever done this in real life, but it's kind of cool. If you just cut a square out of each corner, then you can imagine taking these 4 little pieces and kind of folding them up, and then put a little tape around each corner, and you create just a little box that you can put stuff in. And we want to have the most volume, the most space inside the box that we can. And this is one real application of derivatives, is finding those max and min values. You probably did problems like this in an Algebra 1 class, and you just had to guess and check until you found, the best volume. But the problem is when it's a decimal answer like this one is going to be, you never got exactly the maximum value. So now that we're learning calculus, we can really get a max value. So this is the one where it's not terrible, but it still takes some work. So remember that volume is length times width times height. That's not a 1, that's a length. And so this whole side was 12, but we cut away these 2 little boxes, so that's 12 minus 2x. And this whole side was 42, but we cut away these 2 little boxes, so that would be 42 minus 2x. So I'm going to call the length 12 minus 2x. I'm going to call the width 42 minus 2x, and then the height is going to be that x that we cut out, because that's how tall each side would be, is that x. And it doesn't really matter the order you put these in, so don't worry too much about that. So volume would be the length, which is 12 minus 2x, times the width, which is 42 minus 2x, times the height, which is x. And again, doesn't really matter what order you put those in. And then because we have to find the derivative, it's going to be easier if I actually multiply those and turn them into a polynomial. So a negative 2x times a negative 2x times an x would be 4x cubed. And then you'd have to distribute here and here and combine that. And that would be minus 108x squared. And then the 12 times the 42 times the x is a plus 504x. And I'd encourage you to pause if you need to and check and make sure that this times this times this foiled and then multiplied by x really does equal that. Okay, and then to find those maximum values, remember these are just those extreme points, the max and the min, we're just going to take the derivative. So the derivative of the volume in respect to that x value would be, bring the 3 down front, so that would be 12x squared. Bring the 2 down front, so that would be minus 216x, and then just plus 504. And on most of these, they're not going to factor. And so I would just suggest, to save you time, don't even try, because it just doesn't really work. And so we're going to do quadratic formula. So to find x, it would be negative b, which is 216, plus or minus the square root of b squared, which is negative 216 squared, minus 4 times a, which is 12, times c, which is 504, all divided by, and then 2 times 12 or 24. And I actually plugged both in, the plus and the minus, but only one of them is going to give you a value that makes sense for the length and the width. And that is when x equals 2.755. And they have you round to the nearest hundredth. But to be accurate, it's better to round this one a little bit further. And actually, I just use the answer button on my calculator to keep it really exact, which I really, really suggest. Okay, but that's not what the question asks. The question asks for the maximum volume. It doesn't just ask for that height. So if it just asked for that height, it would be 2.76 is how you would write that. But we actually need to find the maximum volume, which means we need to come back here to this volume formula, and we need to plug that 2.755 into each of those. And again, on my calculator, I just use the answer button. So that would give you a maximum volume of 652.44. I think these were feet, so that would be feet cubed. So that one is what I would consider not too bad, because this just was foiling, was really as hard as the algebra got, was foiling. Okay, but that's not what all of them are, because area and volume is only part of it. We also get these lovely word problems that have to do with distance and time. And so one of them that comes up quite a bit has to do with these poles. So you've got this pole here and this pole here, and this one's 4 and this one's 5, so they're not the same height. And we're basically trying to take a wire and come from here down to some point on the ground and then come up to here. But we want to use as little wire as possible. And so we're trying to minimize this distance, right? And they tell us that this whole thing down here is 7. And we want to find the distance from the first pole. So I made that one x. And if the whole thing is 7 and this is x, then that's automatically 7 minus x. And I would really suggest drawing a picture each time, just to make sure that you kind of can see what's going on and get those values in there, because it's going to make it a lot easier. Okay, but we are concerned about this distance and this distance, right? And so that's just Pythagorean theorem, because these are poles, so those are right angles. So this one here would be a squared plus b squared equals c squared. So that would be the square root of 16 plus x squared. And then this one's a little more complicated. It's still a squared plus b squared equals c squared. But this time I'm going to have to do 7 minus x squared plus 5 squared, which is 25. So just a little bit more complicated. Okay, and then we're trying to find the distance. So distance equals this plus this. So that would be the square root of 16 plus x squared plus the square root of 7 minus x all squared plus 25. And it doesn't really matter when you simplify this. So if you'd like to simplify that right now, you can. And the answer would all come out the same. I'm going to wait and simplify it a little bit later, but it honestly doesn't matter. Remember that you cannot combine these. So that doesn't work to just put it under one square root right now. We've got to take the derivative first. And so I'm just going to kind of imagine each of these to the 1/2 power. And if you want to rewrite it with a 1/2 power, you can. But I'm going to find the derivative. So the derivative of distance with respect to that x value equals, and then I've got to do the power rule, chain rule. So I'm going to go slow and explain, but stop and reverse until you make sure this makes sense. So I'm going to bring that 1/2 down front, power rule, times 16 plus x squared, and then subtract 1, so that's to the negative 1/2 power. But then I've got to do the power rule of what's inside, so I'm going to multiply that by 2x. Okay, that's the first one done. Plus, then I'm going to take the derivative of this guy, so I'm going to bring that 1/2 down front, times everything that's in here, 7 minus x squared plus 25, and that would be to the negative 1/2 power. And then power rule of what's in here, I'm going to have to bring that 2 down front and multiply that by 7 minus x, and that would now be to the first. And then times the power rule there, which would be a -1. Just barely fit that in there. Okay, so make sure, pause this and make sure you know where each of these little pieces come from. And again, the algebra here is what gets a little bit tricky, but that really is just a derivative that we've done before. Okay, and then the idea is, just like always, is we've got to set that equal to 0 to find those extreme points, the max and the min. And this time we're looking for a minimum, right? But this is like a big, huge mess. I am setting it equal to 0, but this is awful. So I'm going to see what I can do. So I know I can cancel that 2 with that 2. That's kind of nice. And I can cancel that 2 with that 2. That's kind of nice. I'm going to leave that x in the numerator. And then I'm going to bring this down to the denominator, 16 plus x squared, and make that to the positive 1/2 power. And then I'm going to probably bring that minus here and make that minus. So this minus and that plus makes that minus. Then I'm going to put that up in the numerator, 7 minus x over. And then bring all of this to the denominator. And this is where I'm going to choose to simplify that. You could have simplified it before. It really doesn't matter when. So simplified, that's x squared minus 14x, and that would be a 49 plus a 25, which is a 74, all to the now positive 1/2 power, and that's all in the denominator. Okay, now notice that we are setting this equal to 0. And so I'm just going to take this whole piece and kind of add it over here, because notice that's a minus. So I'm just going to move the whole thing over here. And to get rid of the 1/2 power, I'm going to square everything, square it all. So I'm going to bring this 7 minus x over here, and I'm going to square it. So that would be x squared minus 14x plus 49. And then I'm going to square this, which really just gets rid of that 1/2 power. So that's x squared minus 14x plus 74 equals, so this moved over here, so that's this piece, and then I'm going to square this piece right here. So that top will just be x squared, and then the denominator is just this with the 1/2 squared goes away, and so that's just 16 plus x squared. Okay, and I'm telling you, it's just algebra, right? Lots and lots of algebra. So what I'm going to do now is I'm going to cross multiply. So here I'm just going to distribute that x squared in. That's not too bad, but here I'm going to have to do a little foiling. Okay, so distributing this x squared in, that would be x to the 4th minus 14x cubed plus 74x squared. And then I'm going to distribute that x squared in. So that would be x to the 4th minus 14x cubed plus 49x squared. And then I've got to distribute that 16 in. So I've got to like foil it in. So that would be plus another 16x squared. And then a minus 224x and a plus 784. You're about to see the magic, right? So see this x to the 4th cancels with that x to the 4th. And this minus 14x cubed cancels with that minus 14x cubed. And that's actually how you know that you're doing it right, is because those are going to cancel on these problems every time. So if you're doing it right, you're going to see that happen. And then I'm going to take all of this stuff and I'm going to subtract it over here to make it equal to 0, so I can do the quadratic formula. So 74 minus the 49 minus the 16 gives us 9x squared. And then add the 224x and then minus the 784, and that equals 0. Okay, and then again, it's no fun, but the only way these really work is just to go ahead and do the quadratic formula. And so just kind of get used to doing that. So x equals negative b plus or minus the square root of, and then b squared minus 4 times a times c all over 2 times 9 is 18. And then again, go ahead and try the positive and the negative, but when you do the minus, you're going to have a negative minus, and it's going to end up negative. So the minus isn't going to work. So it's going to end up being the plus, and you get x equals 3.11. And the cool thing about this is the question just says how far away should that point be? So all it wants is X. So you actually get to stop there. It's just 3.11 feet. If it said, how long does the wire need to be? Then you would have to take that up here and put it into there. But I didn't see anywhere it asked for that. On this type of problem, it always just said find that distance, but please read so that you know what it's asking for. So feel free to rewatch and make sure that you understand. And there is another one where it talks about walking and swimming to reach an island. And I will be doing one of those for our recitation. So I hope that helps.